So let's talk about designing models for 3D printing. Now there's two ways you can do this. One way would be something like FreeCAD or other CAD related software. And the second would be 3D modeling software like Blender. Now people will tell you that you don't really want to use Blender because it's not designed to create precision parts. But this simply isn't true. The fact is a lot of people just don't understand the workflow for 3D modeling and designing 3D parts. So today I'm going to show you how I make precision 3D parts for 3D printing using Blender. So here's my dilemma. I have an audio interface which headphone jack comes from the back. Now you can see I've already solved this. I've created this mount that reroutes the headphone extension cable to the front of my desk, and it's fixed there so I can plug my headphones in right here to the front with no problem. But the other issue is now I have nowhere to put these headphones. So I'm going to solve that today, and I'm going to show you how to make a very simple but precise headphone mount that we can stick onto a desk. Now the great part about this is with today's sponsor PCBWay, you don't even need a 3D printer to begin designing parts for 3D printing. But before we do that, we need to make some changes to Blender. So the first thing we need to do in Blender is to make sure we set our units in our grid view so they're more useful for precision modeling and modeling for 3D printing in general. When you first open Blender, you should be greeted by a default project that has a cube, a camera, and a little sun right here. And the first thing we want to do is just drag, select, and delete all those. We don't need them, just get them out of the way. And the next thing we need to do is go over to our scene and units. So over here on the right, we have this section, this ribbon, and then we have a scene right here. So when we click the scene, the next thing we want to do is go to units. Once we go to units, make sure that's set to metric, and then make sure that the length is set to millimeters. Once you set the length to millimeters, we can come over here and set this to 0.001. And that's going to change the way our entire grid and everything in Blender scales. Now the next thing we need to do is go up here to the view, this section right here, drop this down, and we need to change the scale of our view to 0.1. And what that's going to do is make sure that our orthographic grid is scaling properly to the dimensions we just set over here in our scene. And then after that, we just need to make sure that we change a few things so that we're zooming in and out, our new settings don't begin to clip. So in the clipping, what we want to do is set our start clip to 1, and then for our end clip, we'll just add 2 zeros here. And this will make sure that as we're zooming in and out, nothing we add will just clip out and disappear. Now I hate videos that assumes the worst of the viewer and then slowly drags out every minute detail of the software or the topic that they are demonstrating. So we won't be doing that today. Instead, I'm going to assume that you're an intelligent individual who can quickly track what we're doing and what I'm talking about. If I do skip over something or if you miss something, feel free to leave a comment down below. So now that we've set our scene with our units correctly and made sure that our viewport is displaying how we need it to display, we go up here to Edit and go to Preferences. Once we're in Preferences, we go to Get Extension and we type in 3D Print. And then once you type in 3D Print, just hit Install right here. And then once you're done with that, we go over here to Key Map, and this right here, Spacebar Action. We want to click that to search. By default, it's on play. We don't want that, we want search. The next thing we want to do is go up to the top center of the screen, and we're going to turn on snapping. Hit this drop down and set it to grid. Once you've set this, we can go over to File, Defaults, and Save Startup File. Now every time you open up Blender, these settings are going to load with you so you're ready to design parts for 3D printing. So now that we have our workspace set up and saved as our new default, we can start actually modeling, and I'll show you how this new workspace works in Blender. The first thing we're going to do is go in and add a basic geometric shape, and we could do this by hitting Shift A. This opens up a context menu, and then we just simply go to Mesh and add a cube. This cube is a little large and it's going to fill up your viewport. So let's go ahead and adjust that. The way we adjust this is we go over here to Items. Now you might not have this window. All you have to do is hit the N key and it will open up this side context menu. Once you have this, you click the object and you'll see the dimensions right here. We don't want 200 millimeters. Let's start out with something basic like a 20 millimeter cube. So 20 by 20 by 20, hit enter. And now we have a 20 millimeter squared cube that we can adjust here in our viewport. Now, navigating in the viewport is incredibly easy. We can hold down the center mouse button and then simply orbit around our object like this, and then scroll in and out to zoom in and out. And the next thing we'll learn is hold shift and middle mouse, and then we can pan around our object. These are the very basic controls to navigate around in the Blender viewport. The next thing I'm going to show you is the most important piece to precision modeling within Blender. This is the orthographic view. So up here, you see these axes right here. So we can click the axis that we want to view and edit on. So let's zoom in here to our 20 by 20 millimeter cube. I don't edit like this as a solid object. The way I edit is in Wireframe. So we can go up here to the top right and click Viewport Shading and then click Wireframe. And what this allows us to do is actually see an accurate representation of what's going on with the mesh itself. The last really important piece that we need to understand for our units is how the grid displays these units itself. Up here in the top left, you're going to see that it not only displays the viewport's orientation, but also the primary measurement of the grid. Looking at the grid, we can see there are two different opacities of the grid lines. The brighter opacity matches the central measurements up here in the top left, while the center matches the divisions of that central measurement. So right here, we have a 20 by 20 millimeter cube. So we see up here, this is centimeters. So this would be a 2 centimeter cube that we are working with in orthographic view, looking from the Z-plane. You'll notice that as the opacity in the grids jumps as we zoom out, that the measurement changes in the top left. So centimeters now, and then we scroll out and the opacity jumps to the brighter on the outside and then subdivides the centimeters, and now we're at a 10 centimeter view. And this is the way the viewport works when properly set up to work in metric for millimeters. Now, before we get started, we need to get an idea of the measurements that we're going to use for our headphone holder. We don't want our part to be too big, but we also don't want it to be too small. So we need to take a second and take a few measurements so we have a basic idea of what we're going to do for the headphone holder. So all we're going to do is use a ruler to get the basic measurements. So the width of the headphones, it looks like I want about 5 centimeters. And the inside, we're going to be about 5 centimeters with a standoff of a centimeter. And lastly, all I need is the measurement for the bottom of the desk. I have a frame on the bottom of the desk, and I want to make sure I butt up against that and see I don't stick out too far. So we'll go against that, and that looks like 40 millimeters. When designing parts for 3D printing, it's important to remember that everything in the 3D printing world is done in metric. And that's why it's important to have the right tools to get accurate measurements. I have a few favorite tools that I use myself, and I've made sure to leave these down in the description and with a comment down below where you can pick these up. So from the top of our grid at the Z-axis, we still have our cube here, our 20 by 20 millimeter. Now remember, the bottom of the desk is 40 millimeters offset to the front from the frame. So we need to adjust this cube. And we're going to do this by clicking the object and then hitting Tab to go into edit mode. Once we're in edit mode, we have 3 options up here. We have an options for the vertices, the edges, and the faces. Depending on what you're editing, you can select 1 for vertices, 2 for edges, and 3 for faces. And this really is dependent on what you're editing and what you need to do. So we'll go back into our top Z for orthographic view and adjust this with our edges. So we want to pull off 40 millimeters or 4 centimeters. And the way we do this, again, with our grid is we're using these highlighted lines which say we're in centimeters right here. So we can move this and then click our cursor up here for move. And we'll drag this along the grid until we're at 40 millimeters. Then we can tab back to edit and see that our cube has changed on the y-axis for 40 millimeters. Now, if you remember from the width of our headphones, we need to be at about 5 centimeters. Now, since this is the mounting plate, we're going to go a little bit beyond this and move it to something like 6 centimeters. So again, we'll go into edit mode, hit tab, and I'm just going to drag to select this edge, and I'm going to pull it out right there. And then I'll pull this out too, and you'll notice that I'm not at a centimeter, I'm at a subdivision. 5 and 5 equals 10. So if we tab back out, our size is 50 millimeters right there. So we'll bring it back over and go to 6. And now we have a basic width for the mounting point for our headphone mount. The next thing we're going to do is switch axis over here to the y-axis. Now remember, negative y is towards the front of your build plate on your 3D printer. Since I'm going to be using a basic drywall screw to mount this to the bottom of the desk, I want to make sure that the bottom of the mount is thick enough so that when we screw through it, the top of the screw is not going to come through the top of my desk and damage anything. And right here, we have this at 33 millimeters. So we'll make the mount thick enough so when I screw this through, it doesn't pop through the other side of the wood. Now, since our screw is 33 millimeters and the base of our mounting plate right here is already at 2 centimeters, you would think that we're fine. But that's not exactly true. What we want to do is go back into edit mode, grab this edge and bring it down to 3 centimeters or 30 millimeters. And that's going to allow us to inset the screw into the bottom of the mounting plate. 20 millimeters on a horizontal mount might not be robust enough for what we're looking for. So we'll go ahead and increase that so we can inset the screws, giving us added strength to our mounting base. For the purpose of this video, I'm going to be throwing all the rules of topology out the window. Instead, what we're going to use is basic geometric shapes to block together a very basic design. Now what we're going to do is tab back out of edit mode into object mode, and we want to add another object. So Shift A to add an object, and then we're going to add one more cube. So remember, this cube is too big for our viewport. So the other thing we can do is just hit S and scale it down. So this gets it basically in the view of our viewport. And then once we see the object, we can tap back into edit mode and start grabbing our edges and moving them where we want. So tabbing back out of edit mode, you can see that this gives us our basic 5 by 5 centimeter square base that our headphones are going to sit on. Now we need to go back to our y-axis and make sure that it matches our mounting base. So right here, this doesn't really look like much. We can change our shading and see that it just looks like 2 blocks. That's not a very spectacular headphone mount, but we'll change this really easily. For the section that's going to be holding our headphones, what we want to do is click that object and once again go in edit mode. Once we're in edit mode, we can switch to our x-axis and grab all 4 sides of that cube simultaneously. Then we can go over to Y, and once we're at Y, we'll hit Control B to go into Bevel. And at this point, we can just simply move the mouse to move the corners of those bevels. And I want to put that right about here. Once I have that, I need to go to the bevel window. This may not pop up automatically for you, so all you have to do is hit this. Make sure you don't deselect or click anything else on the screen. Once we have the bevel context menu open, all we want to do is add some segments. And what this does is it rounds out the edge of our headphone mount, giving it a better surface for our headphones to actually sit on. So we can't just have a weirdly shaped peg sticking out the side of our desk. 2 reasons. One reason, it's kind of ugly, and the other reason is our headphones will just slip off the edge of it. So let's add a little bit more geometry to this to give it a better feel and better functionality. To do this, let's click back into the object and then hit tab again to go back into edit mode. Once we're in edit mode, let's just click on the x-axis. Once we're at the x-axis, just drag and select all the edges towards the front of the y-axis. In the next, all we're going to do is zoom it a bit and hit E for extrude. Now what extrusion does is it pulls those vertices and duplicates them forward on the axis that you're dragging. So what I want to do is drag them out about 5 millimeters. Now remember, this is a centimeter plane in our orthographic view. So the subdivisions of 10 would be millimeters. So we're out here at 5 millimeters. Now let's switch to the y-axis. Now we're just going to scale this. So we hit S again, and we'll just drag this out with the mouse. Now you can see that it's not uniformly scaling, but we could fix this afterwards. What I want to do is bring this out maybe about 3 millimeters and then just click. Now it's still not uniform, so let's get that a little more uniform. What we want to do is make sure that we scale it on the plane where it's a little bulged out. So we can hit S again and then hit X. And that will only scale on the X plane. So we could bring that a bit in, and that looks a lot more uniform. Coming back over to the X axis, we can extrude one more time and bring that out. And then tab back out of edit mode, and then here is our object. Now that we've done that, our mounting block is starting to look a little bit neglected. But we can fix that. We can click on this again and hit tab to go back into edit mode. And let's go back up here to the top right and change our viewport shading back to wireframe. And then let's go back to our Z-axis because I've just changed my mind and decided I want just a little bit more for our mounting width. Now that I've increased the width of the mounting bracket, I'm going to change my view on the axis. So I'm going back here to the -y. And what I'm going to do is drag and click these corners right here. This will select the edges of that object. So back to our Y, and then I'll hit Control B again to add another bevel. So we'll simply go right about there. That looks pretty good. So now, if we go back to our viewport shading and change it, you can see it looks a little bit more uniform and acceptable for a mounting bracket underneath the desk. Now, if we stop for a second, we'll notice that we have a big problem. Blender doesn't automatically just start saving your file as you're editing. In the top left, it says unsaved. So we need to go ahead and make sure that we save this file. And there we go, our file is saved, and I don't have to have an emergency and restart the video. So going back into wireframe mode, I'm going to show you the reason that I had you get the 3D print toolkit earlier. So we can select an object right here and hit 3D print, and what we want to do is hit check all. And this is going to run a check on the object we selected. And the most important thing we need to make sure is that there are 0 manifold edges. Manifold edges show up quite often when you're doing things like beveling a part or even doing a Boolean. And a Boolean is something we're about to do right now. So let's take a second to talk about the sponsor of today's video, PCBWay. As I said in the beginning of the video, you don't even need a 3D printer to begin designing parts for 3D printing. PCBWay has an incredible line of services that can help you get your parts manufactured easier than ever before. These services not only include 3D printing, but CNC machining, sheet metal fabrication, and injection molding. You can even design custom circuit boards and electronics for your projects and have them manufactured and shipped directly to your door. There has seriously never been a more exciting time to start designing parts for your own projects. With PCBWay, you select the service that you're looking for and then upload your designs to the website. Once you've done this, you just fill out any parameters that you're looking for and the quantity that you're wanting to order. Once you've done this, their team of engineers even reviews your project to make sure that there's no issues before manufacturing. So if you have a project that you want to get started, make sure you check out today's video sponsor, PCBWay, at PCBWay.com. When you look at this part, you realize there are no holes for the screws to go through. And we don't just want to ram a screw through. That's not a good part design. So what we're going to do is we're going to add a Boolean cut to this object right here to allow us to put our screws through. In Blender, there are several ways to add a hole through an object. But the most common of those ways is through a Boolean. The way a Boolean works is when you add this modifier, the selected object will cut away any intersecting object that is selected through the Boolean modifier. To do this, we'll hit Shift-A and add a cylinder. Now we can add a cylinder here and just scale it down. The width of our screw is about 4 millimeters. So what we want to do is make sure that this hole passing through is a little larger than that so our screw freely passes through our mounting plate. So let's zoom in until we see our millimeters, and then we'll go ahead and move this cylinder. And we'll move it right about there. So here's where the precision of the mesh comes into play again. Now you see the millimeters right here, and what we want to do is scale this until we're about 5 or 6 millimeters. We're going to go 6 so it guarantees that our screw freely passes through. And the head of our screw is even larger, so we don't have to worry about it going completely through. So we'll go to 6 millimeters, and you can see right here on the grid, 1, 2, 3, 4, 5, 6 millimeters. We don't have to use any rulers or any measurements like that. We're using the grid the same way that you would use it in art drafting. Now that we have this the correct size, we want to go ahead and copy this and paste it. And we'll drag it over here as a duplicate object. Select both and hit Control-J to join those two objects. Now we can't just add the modifier here and select this because they're not punching through. What we need to do is change our axis to the Y-axis and make sure that this completely intersects the object that we're trying to use the Boolean modifier on. Now you can see I've dragged that all the way down so it passes through. And now we can select this, and there are two ways to get to the Boolean modifier. One of those would be to hit space for search, and we just type in Boolean, or boo for Boolean. And the other way to do this is to go over here to this panel. This panel right here has all these different options, and the wrench right here is modifiers. And then we just add right here, search, and then we'll look for Boolean. I've already used it, so it's at the top. Once we have the Boolean modifier added, we can go in here for our object and select the object that we want to cut through our object. Then we can come over here and hit drop down and then apply. And now if we look right here and hide that, we'll see that we have our screw holes punched through our mounting plate. So let's take this one step further. Let's go back to our wireframe and back to our y-axis. And what we want to do is bring back that cylinder that we just hid. We'll click that and go in edit mode, and we'll just delete the vertices on one of those. And now we just have one cylinder here again. So in edit mode, we're going to hit A to select all. This will select all the vertices inside of an object once you're inside edit mode. And now we're going to hit S for scale. Let's click our Z plane, hit S for scale, and bring this out a little further. And we can bring it out, let's be ridiculous. Bring it out right there. We'll come back to our Y plane, and we see we don't want to completely intersect this part. All we want to do is inset the screw head. Select these edges down here, and then bring these up. And then right here, we can inset that a whole centimeter, which gives us the 2 centimeters here that we need for our screw mounting. So hit tab, we'll select and copy this object. Now you'll notice once we copy the object, we're very far off on our tool. So the way we fix this is go into objects, we go to set origin, set to geometry. That will set it to the center of the geometry of that object. Now we can drag this over here and then join those objects together. Now those are joined together, let's go back over here, hit space, and type in Boolean. And let's add this modifier and then select the object that we're going to use to cut away. Once that's done, just hit apply. Now we can get rid of this right here. And you can see our screw holes are inset now for our drywall screws to be used on the bottom of the desk. From here, there's really no reason to drag this out. I've showed you the basic steps you need to take to begin designing parts for 3D printing in Blender. So out of respect for both of our time, I'm just going to go ahead here and skip to the end, clean the model up, and do a little bit of a facelift. And at this point, we'll just jump, and I'll show you the printed model. I just hit A to select everything in the viewport, go up to File, and go into Export. Export it as STL, and we don't need to make any changes. All we do is hit Export STL. So here's our part, fresh off the printer. And at this point, all I need to do is install it on the desk. But while I was away, I added a little bit of an extra feature. Wouldn't it be cool if our headphone jack was just inside of our headphone mount? So that's how we design parts in Blender for 3D printing. Once you learn the workflow, it's incredibly easy to get going with any ideas that you just might have. So if you want to design your own files for 3D printing, go ahead and give Blender a try. Keep in mind, no program is mastered overnight. Just go ahead and learn the basic steps and start from there. Anyways, I'm ZeroCMD. Thanks for watching.